Technology is breaking the barriers between the physical and the metaphysical. The things considered to be science fiction are gradually becoming our reality. If you're a fan of the X-Men movie franchise or the Netflix series, Stranger Things, you'd have an idea of what telekinesis and telepathy are. But what you don't have an idea about is the fact these aren't just mere science fiction. Just like other technological advancements that have become our reality through their exposure in movies, recent studies show that it's actually possible for telepathy and telekinesis to exist in our world. This means that one day, we as humans would be able to control objects without touching them and be able to communicate with only our minds. I know it sounds insane, but as I speak to you right now, scientists from around the world have opened the door to these abilities using what's known as metasurfaces. So the big question here is, what are metasurfaces and how is this possible? Let's talk about it. Just so we're both on the same page, I'd assume you have no idea what telepathy or telekinesis means. So we'll break them down one at a time and see how it's a feasible technology. Let's talk about telepathy. Telepathy is the psychic ability to communicate with another being by using only your mind. So for instance, I communicate with you not with words or body language but simply with my mind. And also, you understand what I'm trying to say or do by also using your mind. It could also be communicating with computers or any electric system. If you're familiar with the fictional character, Professor X, in the X-Men movie franchise, you'd see scenes where he communicates with other characters by using his mind. That's a perfect example of how telepathy works. On the other hand, telekinesis is the ability to control physical objects at a distance without any form of physical contact. This can be seen exhibited by the little girl in the 1996 movie Matilda, and by Luke Skywalker in Star Wars: The Empire Strikes Back. Now obviously these ideas came out of a creative mind and are pure fiction. However, they just might have solved an underlying problem in our society. For example, think of people who are disabled and can't seem to get simple work done due to their disability. An example can be typing a text or taking out the trash, or even using the remote to control the TV. These are things disabled people can't do now, but would be able to do if they had telekinetic technology. Another one could be people who have acquired apraxia of speech, which is basically the inability to say an understandable sentence, or the inability to speak at all. If they had telepathic technology to aid their speech, everyone would be able to communicate with them. So now we know these abilities are beyond fiction, and thankfully, a group of scientists halfway across the world have created a solution that could not only solve the problems I just stated, but also change the course of humanity forever. How did they do it? Well, it's simple, by using what is known as metasurfaces. Metasurfaces are the two-dimensional version of the three-dimensional metamaterials. Metamaterials are simply composite materials with certain properties that aren't exhibited by normal materials. Examples of these properties are dynamic camouflaging and invisibility cloaks, but we're not talking about the type of invisibility you see in the movies Casper the Friendly Ghost and Harry Potter. We're talking about another type of invisibility. Take for example, you painted your entire body black and hid in a coal mine. It'll definitely be harder to spot you than if you were painted white. This means that the invisibility of metamaterials is achieved by bending light waves surrounding a cloaked object in a way that the observer sees the other side of the object, just like his view was never interrupted. There's a whole deeper explanation to this. However, we're not concerned with all that right now. What we're concerned about are metasurfaces. Imagine the normal physical properties of a material, let's say glass bottle. You would expect a glass bottle to shatter under pressure, and also expect wood to crack as it gets dry. These materials exhibit these properties because they have consistent behavior, but when it comes to metasurfaces, they do not have a consistent behavior, giving them unprecedented freedom to exhibit any property. But this can only be achieved by manipulating electromagnetic waves surrounding the metasurface. As you might know, electromagnetic waves are produced by a generator. But did you know that there's a complex organ in you right now that constantly generates these electromagnetic waves? If you didn't, this organ is your brain. The human brain constantly generates electromagnetic waves as we absorb every ounce of information. Scientists have found that the electromagnetic waves generated by the brain can be controlled and even shifted from one form to another. They also found that these electromagnetic waves can be picked up by a cap-like structure bombarded with electrodes. So if you need electromagnetic waves to manipulate the properties and behavior of metasurfaces, and our human brain can generate these electromagnetic waves, does that mean we can use our brains to control metasurfaces? The answer is yes, and that's where telekinesis technology comes in. A group of scientists recently published a case study for this in a tech journal. The team, led by Professor Xiaobo Ku and Professor Jiafu Wang from Air Force Engineering University in China, and Professor Cheng-Wei Chu from the National University of Singapore, had very detailed insight into how this is possible. The major aim was to make remote, real-time, mind control of metasurfaces and even metamaterials using Bluetooth. The first step was to design programmable metasurfaces with the ability to switch from one state to another using a set of software. Next, they designed a brainwave extractor that has three fundamental parts: the actuator, the sensor, and the controller. The sensor is the part responsible for collecting brainwaves through the electrodes in the cap placed on the scalp of a human. The collection of these brainwaves is aided by a commercially available chip known as ThinkGear AM, which converts the brainwaves to be collected to the attention value of the human. So depending on whether the brain is in a relaxed or concentrated state, the brainwave collected will vary. Once the brainwave has been collected, it is recorded and sent to the controller via Bluetooth. The controller then sends the brainwaves to the actuator, which binds the brainwaves and outputs them in different voltages. The outputted voltages correspond to a logical sequence of 0 and 1. These voltages are responsible for how the metasurface can be controlled. So depending on whether the brain was relaxed, distracted, concentrated, or fully concentrated, the brainwaves generated would be different, and in turn, control the metasurface differently. But they didn't just end things there, they carried out a physical experiment of their theory. A female volunteer was taken to a room completely soundproof with no other generator of electromagnetic waves present. She was asked to close her eyes and circle through the 4 different attention states. As expected, the light scattering property of the metasurface was seen, but what the experiment really proved is that there is a direct relationship between the attention state of the volunteer and its impact on the property of the metasurface. Well, even if it looks cooler when Professor X or Jean from the X-Men do it, this study on telekinesis doesn't show that we can move materials physically. However, it has opened the door to the possibilities of controlling material with our thoughts, remotely, and in real time. It paves way for more intelligent use of metasurfaces. In the health sector, to intelligently deliver drugs inside the body using 3D printed millirrobots, or in the communications sector to bolster advancements in 5G and 6G. And if you thought that was crazy, then telepathy would definitely blow your mind. Telepathy or brain-to-brain communication is not really new to mankind. Metasurfaces have provided a better and improved paradigm for telepathy, but the foundation of their experiment was built on previous works. Apart from the numerous movies that have been centered on this super ability, a few experiments have been conducted to test its feasibility. One experiment that really stood out went like this. 5 groups of 2 volunteers each were selected to play a game of 20 questions. The goal was for a member of each group to pick an object out of 8 random objects and for the second member of the group to try and guess what object was selected. So for instance, if volunteer A selected the object dog, the brainwave was collected and recorded using an electroencephalography cap. With a click of a mouse, an associate question was sent to volunteer B. Questions like, does it bark? Or is it a mammal? Volunteer B would then be required to answer by looking at 2 flashlights placed at the corner of both their eyes representing either yes or no. The answer was then emailed to volunteer A, who would see a bright light if the answer was yes or wouldn't see any light at all if the answer was no. Now, this experiment was conducted on a university campus with both volunteers just kilometers apart. It required a screen, an internet connection, and lots of wires. Even though the experiment was 75% successful, a team of scientists at the Institute of Electromagnetic Space, Southeast University in China, couldn't help but ask the question, can metasurface do it better? The team led by Dr. Tai-Jun Kui designed a non-invasive electromagnetic brain-computer metasurface for direct communication, using only the brain to communicate our thoughts. According to Dr. Tai-Jun Kui, we got our inspiration from brain-computer interfaces used in rehabilitation technologies for nerve system impairments and amputation. But the most fantastic thing about their telepathy technology is how it works. Similar to telekinesis, an electroencephalogram sensor, also called an EEG sensor, is worn on the human scalp to convert brain waves into electric signals that are seen on a computer. The converted signal, called the P300, is then combined with a specific type of metasurface known as the information metasurface, with the logical sequence of zeros and ones. They put two volunteers together, with one to act as a transmitter and the other as a receiver. The transmitter's brainwaves were monitored using the EEG sensor. The brainwaves were then converted into the P300 signal, decoded to its logical sequence, and used to control the transmitter's information metasurface. Here's where it gets really interesting. The information metasurface of the receiver also experiences a change in properties as a result of the change in the transmitter's metasurface. That change results in the reversal of the logical sequence from binary to text information for the receiver to understand. The experiment successfully translated 4 phrases: "Hello world," "Hi, Sue," "Hi, Scut," and "BCI metasurface." Keep in mind that the entire process was wireless and used only human thoughts and brainwaves. Fantastic, right? Well, that's for you to decide. The process is kind of slow because it took about 4 to 5 seconds to print out each character, but that's the littlest of problems because quick spelling paradigms can be implemented. Obviously, these technologies still have a long way to go before they become mainstream. Regardless, it's an amazing milestone achieved to augment technological success. What do you think about them, and which one are you more open to testing out? Let us know your thoughts in the comment section below. Bye for now.